Good everyone, my name is Graphics. If you look at the front of your screen, you see a question that is displayed there, and that question is under a subtopic in statistics, which is probability. What we're looking at what? Set theory. So we're looking at set theory in what? In probability. Now, and the question says, from the question, it reads, it says, an electrical engineer, or will I say a mechanical engineer, has on hand two boxes of resistors with four resistors in each box. The resistor in the first box are labeled 10 ohms, but in fact the resistances are 9, 10, 11 and 12 ohms. The resistor in second box, that is box 2, are labeled 20 ohms, but in fact the resistances are 18, 19, 20 and 21 ohms. The engineer chooses the resistor from each box, determine the resistances of each. Let A be the event that first resistor has a resistance greater than 10. Let B be the event that second resistor is resistance less than 19, and C is the event with summation equal to 28. Find sample for this experiment and specify the subset corresponding to event A, B, C. Are we together now? So this is what we have. So before I move forward, they say you cannot withstand what you don't understand. So let's understand what we are trying to withstand. First thing we have in this our question, we talk about probability. We have what they call sample space, and we have what they call events. Now, what is the probability? Probability is just the measure of likelihood that an event will occur. The likelihood that I'm going to upload the video that that you're watching now is 0.5. It's half of the chance. And the likelihood that I will not upload it also half of the chance. That's what we call probability. Probability that I will succeed is 50%. And probability that I will not succeed is also 50%. Now, we'll now look at sample space. Now, the sample space is a set of all possible outcomes of a random experiment. Like if I pick up a coin and I toss the coin, the sample space of that coin will be head and tail. Why? Because the coin has two faces, the head and the tail, because I tossed it once. If I pick a die and I toss the die once, the sample space that what I'll have will be what? 1, 2, 3, 4, 5, 6, because each of the face of those dice is 1 to 6. These are what? That what we call what? The random experiment, the outcome that we are going to have. Now, what are the next things? We'll talk about the event. Now, the event is just a subset of the sample space. The event is what? Is a subset of what? Sample space. Is what you get from the sample space. That we'll call what? The event. Now, let's now kick into business. For our question, the first thing we are told to do here is that we have two boxes of resistors. We have box 1, let's call those box 1 and what? Box 2. Box 1 has resistors that have resistance of 9, 10, 11 and 12. Put them in bracket this way. Box 2 have resistors that have resistances of 18, 19, 20 and 21. Right? Now, we are now told, first thing we are told to do is what is the sample space of these two resistors, of these two boxes. What you do is, to get the sample space, we say the sample space is what? The set of all possible outcomes of a random experiment. Now, we'll pick these two experiments in box 1 and box 2, we'll take them randomly. Now, that means our sample S will now give me, you take 8, 9, you pair it with all resistances you take 9 in box 1 and pair it with each of the resistances in box 2. And when you do that, you're going to be having 918, 919, 920, 921, right? That's what we're having. If you take 9, then you go again to the next resistance in box 1, which is 10, and pair it with all the resistance in box 2. And that will give me 1018, 1019, 1020, and 1021. You go to the next resistance in box 1, which is 11. You'll now be having, you pair it with all the resistance in box 2. So you'll be having 1118, 1119, 1120, and 1121. You do the same thing for 12, and you'll be having 1218, 1219, 1220, 1221. So all this you see here is the sample space of these two resistors with their resistances. These are the possible outcome that we can get when you pair, when you select this at random. So we solved the first question here. Now the next question here, they now gave a condition. They says that let A, right, be, from the question here, it says let A be the event that the first resistor has resistances greater than 10. That is the first thing. So you write let A such that the first resistor, which is our box 1, has resistances that are greater than 10. Write it this way. So it means that from the box 1, what will now be my outcome if you have the condition that the resistance in box 1 must have resistances greater than 10. So when you say something is greater than, means you not start from that thing. If I say greater than 2, means from 3, 4, 5, 6. If I say greater than 10, means from 11, 12, and so on and so forth. So when you say greater than 10, and in that box 1, I have 9, 10, 11, 12. It means that I'll cut away from 10 downward, and I'll have the outcome I'll be having remaining will be what? 11 and 12. So the outcome in box 1 is what? 11 and 12. I write it out this way. So I will now, for me to now get my subset A to now be equals to, I will now take each of these resistance in the outcome. So since I'm doing box 1, I will now focus on box 2. So I will take each of these resistance and pair it with all the elements in box 2. So we're having 11 with the pair with 18, 11 and 19, 11 and 20, 11 and 21. I'll go to 12 again. I'll take 12 and 18, 12 and 19, 12 and 20, 12 and 21. So this is my subset A. I put together now. So we are done with that, with the condition. Then the next condition, it now went further. I'll say let B such that, that is the subset B, such that box 2 will be less than 19. So that means less than means you are going down, right? So when you say less than 19, when you say less than 5, means you start from 4, 3, 2, 1. Less than D, you start from C, B, A. So when you say less than 19, you start from 18. And recall, we only have 18, nothing is after 18. So the outcome for that condition for box 2 will now be what? Will be 8, will be what? Will be 18. All together now. Now if I want to now get my subset B, it will now be this 18 will now be paired with everything in box 1. Since 18 is in box 2, you are meant to pair with resistances in what? In box 1. So it will now be 18 and 9, 18 and 10, 18 and 11, 18 and 12. That will be my subset of what? Subset B. Now the next one here is now for C. It says that C should be the sum that the sum of each pair will be what? Will be 28. Remember, our point of reference is box 1 and box 2. So you go back to box 1 and box 2 now and see if each of the pair from box 1 and box 2 will be what? 28. So let's start. If I take 9 and 18, right? Will it give you 28? No, it will not. If I take 9 and 19, will it give you 28? Yes, it will be. So one of my subsets of the element in C will now be 9 and 19. I'll go to the next one again. 9 and 20, will it give me? No. 9, 21, will it give me 28? No. I'll come from 10. 10 and 18, will it give me 28? Yes. So another element will be what? 10 and what? And 18. So if you do the same thing all through, you will come to 10 and 19, no. 11 and 21, no. 11 and 20, no. 12 also, none of them again. So we only have just two of this element in C. So my subset of C is what? 9, 19, 10, what? 18. So this is what we have. So we successfully answered the question. We've gotten the sample space. We've gotten the subset A, B, and C. And that is all for this question. So if you found this video helpful, please don't forget to like the video, subscribe to the channel, and also share the video. Watch out for more.